Sine of the absolute value of x plus 1. And it says find all values of x when the function is differentiable. Well, when is a function differentiable? Okay. By the way, we should all be in courtesy mode. Thank you. Eyes attentive on the board because this is important. All right, so when is sine of absolute value of x differentiable? Well, for the most part, it's easier to determine when it's not differentiable. So if we go to page 109 in our textbook, we see the 4 scenarios in which a function is not differentiable, okay? So the first scenario is if we look at it graphically and we see a corner, it doesn't differentiate. It's not differentiable at a corner. Next option, it's not differentiable at a cusp when it comes to an abrupt point like that, which is like a corner, but it's a curve coming into the corner. So that's a cusp. It's not differentiable when we have a vertical tangent. So if I were to draw the tangent line, we'll do this in yellow. The tangent line at x equals 0 is literally a vertical line. So vertical tangents are not differentiable. And in the other situation where it's not differentiable is if there's a discontinuity. And the kind of the informal, well, it's more of a formal, but I mean my informal plain English explanation is my derivative as I approach 0 from this side is completely different. Well, no, I can't say that. It's not continuous, basically, is what I'm saying. It's not a removable discontinuity. So whenever you see a jump discontinuity, not differentiable at the point where the jump discontinuity occurs. So here, when x equals 0, because of the jump discontinuity, I just can't find the slope. Right? So the slope of the tangent line is the derivative. So when we say is it differentiable, what we're really trying to determine is it possible for us to make a tangent line, and when we make that tangent line, what would the slope be? Well, this one we can't do it because the mathematics is weird. If I go to find the slope of the secant line, I get infinity or negative infinity. This one I can't do it mathematically because of the jump discontinuity. This one I can do it, but the slope as we approach from the right-hand side is different than the slope from the left-hand side. So I can't really determine the tangent line. I mean, I could draw a line and say the tangent line has a slope of 0, but there's some formality that we have to think about too. And the same thing here. The slope from the left is completely different than the slope from the right. So we run into an issue there. So when we go back to problem number 33, I guess what I want to do is I'm just going to graph this function, and then I want to ask myself, do I see a corner? Do I see a cusp? Do I see a jump discontinuity, or possibly is it a vertical tangent line, right? So let's just graph it and see. So let me pull up my graphing calculator. Oh man, I've got a bunch of stuff open. Okay. And so if I pull up my graphing calculator, and I graph this, I'm going to say a sine of the absolute value of x, and I think that's -1, right? Now I don't really see like a cusp, and I don't really see, just by looking at the picture, do you see a cusp or a corner or a jump discontinuity? No. So what does the back of the book say though? Is there an issue where it's not differentiable, or is it differentiable across the domain? At x equals 0. So now what I need to do is I need to zoom in. So if I zoom in at x equals 0, now let me come down just a little bit, bring my cursor to where, oh, see what happens when I zoom in a little bit? What does that look like right there? That's a cusp. Okay? So that's one of the things we have to be careful about. Now, I did that on purpose because I want to show you another way that you could look at it. When we look at things graphically, sometimes we got to zoom in and zoom out to see where the issue is. But one way is that we could look at the table of values. All right? Now, let me show you something here. It's approaching -1. The value is -1, but now look at the growth or the decay or how it changes. If I come in and I look at the table and I start at 0 and I choose like kind of a small increment and I hit second table, I'm going to see that they both approach 1, but what do you notice the way in which they approach? So look at the table of value. I guess let me rephrase the question. What about the table of values can you notice or observe that help you to identify this as a cusp? Yeah, they're symmetrical, right? Definitely, but they're both approaching -1 from the same direction. In other words, here I have, if I come over here, I have -6 to -7 to -0.8 to -0.9 to -1. From here, I have the exact same thing going on. Now, what that translates to graphically is that as I trace through the function, in other words, as I come through from this side, as I approach 0 from this side, these are my corresponding y values. And as I come through from this side, it's the same y values but mirrored. Sorry about that. But mirrored, right? And so you can look at that and kind of, it doesn't mean that it is a cusp, but those are some things you can look at. Now, if it was different, in other words, if I looked at my table of values and let's say it approaches -1 and then this isn't -9, it's like -1.1 or -1.2, well then it's clearly not a cusp. Does that make sense? So I get to -1 and then now if this value was -1.1, then we know that it's not a cusp because the trend continues. If it is symmetrical, there's a good possibility that it's a corner or a cusp. Yep. If it's not, then you're pretty safe to say that a cusp doesn't exist or a corner doesn't exist. And right. So like look at this. So here's what I'm saying, and this is what it looks like on the table of values. If I were to draw a line through this cusp, the y values would be the same, right? For different x values as I approach the corner. And the same thing for this cusp. If I slide the cusp over, there's that symmetry. Now in this case, it's the symmetry across the y-axis, but it's the symmetry as the y values. So it wouldn't necessarily center at x equals 0. Sometimes it'll center at x equals 1 or whatever. And that's what you would have to look at. Okay? All right. Good. Any more questions on